Hello guys and welcome again. It's your teacher again, Mr. JF Chavangwana. So we are back with some exciting content. Today we are focusing on mathematics grade 11 and 12. Under mathematics we are looking at algebra. Under algebra we are looking at quadratic expression and the nature of the roots of quadratic expression. So now I have selected some of the questions that I believe they are a challenge to the learners. So in this video we'll be solving quadratic expression and as well as to identify or determine the nature of the roots that we get from a quadratic expression. So let us start by defining a quadratic expression. When we are talking of a quadratic equation is any polynomial which has the highest power of 2. Right, so any polynomial with the highest power of 2, it is a quadratic equation. So it has the format ax squared plus bx plus c, where a, b, and c, those are real numbers. So let's say this was a function of f of x. So let's say this was a function of f of x, right? So that is a function of f of x. It's a quadratic because the highest power here is 2. So any equation or any polynomial with the highest power of 2 is regarded as a quadratic equation. So now the first section under quadratic equation, I want us to learn how to determine the maximum and minimum values. So now if this was a function of f, now to determine the values you can draw your function, right? So to draw your function, you see the values of a, analyze the values of a, to sketch your graphs, right? So when you are sketching your graphs, we see that if a function here is smiling up, so that means a is greater than 0. So in this case it will have a minimum value. If your function now is smiling down, that means a less than 0. That means here we have a maximum value of a quadratic function. So you must see that it is a minimum because this is the lowest value of that function where a is positive, and here it is a maximum because that is the highest value there. So this becomes our maximum, right? So that is a maximum. And then as well, how do we determine those values? Now I have chosen one. There are many methods to do this, but now for this video I have just selected one method. So we will use calculus, which is a topic that is done in grade 12. So if you have not done it, it doesn't mean you cannot do it, because it's simple, right? So to determine the maximum and the minimum values, you have to let your f prime of x equals to 0. F prime is where you derive your function of x. F prime of x, you derive the function of x and equate to 0. So in this case, how do you derive? To derive a function, you take the exponent, this exponent, times the coefficient of x and subtract a 1 from there. So in this case, to differentiate, we take that exponent times there. So you say 2 times a. From that exponent, you say 2 minus 1, right? So you subtract a 1 plus, right? So in this case, what is our exponent here? Our exponent is 1. So you say 1 times b. So 1 times b x to the power 1. From that 1 you subtract a 1 plus c. If there's a constant term without an x, so you can put x to the power 0. X to the power 0, anything to the power 0 is 1. So this thing is the same as 1, right? So a constant has a term of x, which is x to the power 0. So how do you differentiate? You say 0 times the coefficient here is 1. So you have 0 times 1, c to the power, c is 0 times 1, c, x to the power 0 minus 1, right? Is minus 1. Okay, so what do we have here? Here you have 2a, here you have 2 minus 1, so you have x to the power 1. Even if you don't write that one, is not important, by the way. That one is not important. So you have 2ax plus, in this case, 1 times b is b. X to the power 1 minus 1, you get x to the power 0. Anything to the power 0 is 1, so there's no need to write a 1 there, so you get that. So here anything times 0 is a 0, so you don't mind that part, this part, because it's times is 0. So you get your first derivative of your function of x equals to that. So at the maximum point we said f prime of x must be 0, so this part here, f prime of x is equal to 0. Then you have 2ax plus b, right? So how do you solve for x? Let's rewrite this equation like 2ax plus b equals to 0. So how do you solve for x? You transpose the b to that side, then you remain with what? 2ax equals to negative b. Then to find x, you divide by the coefficient of x, which is 2a, both sides, 2a. So what is the x value at the maximum point of any quadratic equation? X is equal to negative b over 2a. So this is the general expression of finding a maximum or a minimum value of any quadratic equation, right? So you do not have to differentiate the equation that you are given and end here. You can simply come from here and find the value of x. After finding x, you substitute in the original equation to find the corresponding y value. So now let us look at the problem where we apply the knowledge here. Now let's find the maximum value here of the expression. Let's see, we have a question. We are supposed to find the maximum value of this expression. Find minimum value. We find minimum value of which expression? Minimum value of 3x squared plus 4x plus 1. So we are given this function. We are asked to find the minimum value. The minimum value, why? Because a is positive, and when a is positive, your function will have a minimum value. If a was less than 0, you are going to be asked to find the maximum value. So in this case, we find the minimum value. How do you find the minimum value? You differentiate this expression. How do you differentiate? Take this exponent times the coefficient there. So you have 2 times 3x to the power. From 2 you subtract 1 plus, then you have 1 there as your power, which is not returned. Then 4 times 1 x to the power 1 minus 1 plus, you see now you have a constant term of 1, so you can put x to the power 0 there. So you have 0 times 1x to the power 0 minus 1. So what do you get? You get this thing equals to 6x. 2 times 3 is 6. Then here you have 2 minus 1. That means it's to the power 1. So anything to the power 1, you don't have to write that one. Then here you get plus 4, because 4 times 1. And then here you have this term 1 minus 1. You'll have x to the power 0. So there's no need to write x to the power 0, because there will be 4 times 1. And in this case, anything times 0 is a 0. So a derivative of a constant is 0. And then you equate everything to 0. The first derivative of your function must be equals to 0. So what is next? Then you have 6x. Then transpose the 4 to the other side. You remain negative 4. To find x, we divide both sides by 6 by 6. So what we have, x is equals to negative 4 over 6, right? So now look, we will do the same question, just we use this expression. So you did not have to do everything, everything that we did here. You can simply use the term x equals to minus b over 2a. Let's see. We don't have space, so our equation was 3x squared plus 4x plus 1. So let's see, what is our a? Our a is equals to 3, our b is equals to 4, our c equals to 1. A is the term that has x squared, b is the term that has only x, c is the constant term. So how do we find it? We say the equation is saying x is equals to minus b over 2a, right? So what is the value of b in this case? The value of b is 4. So you say minus what? 4 over 2 times a. What is our a? Is 3. So you get negative 4 over 6. So that is the same answer as that one. So this equation is used to find the x value of any turning point, or the x value of your maximum point. Then to find the y value, you take this x and put it back to your equation. Where there is that thing, you put, where there's x, you put that and find the corresponding y value. So it will be 3 negative 4, right, squared plus 4 negative 4 over 6 plus 1. Then you press in your calculator, you find the maximum values of that graph, if it was a graph, right? So that's how you find the maximum values of any quadratic equation. So now we move on. In the next section, we are looking at the nature of roots of quadratic equations, right?